Welcome to WXTV, your online source for weatherization training. Before we pick back up with part 2 of blower door basics, where we actually start the test, we wanted to share a segment we shot with a special guest. Anthony Cox stopped by WXTV studios a few weeks ago, and of course he's well known for his house of pressure. We asked Anthony to say a few words about building science.
Yeah, I mean that's the big thing, is getting folks to understand that it's not just a caulk gun and a hammer, that it is some science to this. You got air, heat, and moisture. Those are like your 3 big things, in physics and kind of things that go along with that. Because when we touch a house, we're changing the way the house works, whether we know it or not. We're air sealing something, we can affect the way the chimney works. We could be. So health and safety is really the big thing. So people need to understand it's not just going in and air sealing to make it more efficient. You have to think about the air sealing aspects, the moisture aspects. Am I going to endanger someone's life or the durability of the building? Right. So, but you get the efficiency along with it. Doesn't mean that you don't want to do those things. It's just that you have to have a good background or understanding of that building science concept, the interactions that go on in a house. Everything from the HVAC system to the insulation to the air sealing to the moisture levels, So you have to, it's a lot that you have to think about, especially the person that's doing the write-up in the work scope, because they have to, think about all those things. And then the guys out in the field or the crews out in the field, they have to understand the details of the work that they need to do to accomplish it correctly. I mean, I can just caulk something or seal something, but if it doesn't have anything to do with where the air's coming in, then I'm maybe just wasting my time. So you got to have some directed air sealing. You use your blower door test. You don't just use it before and after. Sometimes it's good to use it as you're sealing and kind of checking things. Did I get this airtight? And for attics, for instance, if I'm insulating an attic, I don't just go in and blow the insulation. I've got to go in and do that air sealing. And it's good to check that air sealing before I put the insulation in, because if you miss something and then you go back and find out with the infrared or your blower door test that I missed it, now how hard is it to go back, through that insulation,
get through it all
and fix that? So it's understanding those things. And another thing is, for people that are new to it, is just all the terms that are in weatherization, bypass, backdrafting, CAS test, combustion appliance, and all those things. So it's, that building science knowledge of it and how things work together. If you're going to really make a house that works, the whole house weatherization type concept, you got to look at the house as a whole and the way it interacts as a system.
So we're picking back up with the blower door process, and we're just about ready to start our test. The first thing we got to do is take a baseline, and what the baseline does is it accounts for the pressure that's already in the house. So this is a DG700 manometer. A lot of weatherization folks are using it, so we'll go ahead and show our test with that. You see in the upper left hand corner here, just to make sure we have the right blower door setting, BD3, that's the model of the fan that we're using. So the test we're running is a pressure and flow at 50 pascals. You see that in the lower left-hand corner of your screen. That's just gotten to by pressing this mode button to cycle through the different tests that the unit can take. So to take the baseline, we just go ahead and press the baseline button, and you'll see that flashing there. And we can start the process. And you see we're getting right around 0.9 pascals. That's pretty normal. On the right-hand side, it's counting down in seconds how long you're taking that test. You're just waiting until this number here stabilizes. And I'm not seeing a lot of movement there, so I'm going to head and press enter, and we've locked that baseline in. And now what we want to set is our time average. Now this is how many of your readings you're averaging together to get your readout in the main portion of the screen. The default is 1. The DG700 takes a reading every 1 second. Now if you want to average every 5 readings, you set it on 5. Every 10 readings, you set it on 10. And if it's windy outside and you're getting a lot of fluctuation with these numbers, you may set it on long, which means that it's going to average each number with all of the numbers that it's picked up beforehand. So we're ready to set up our fan and put in the proper ring. Now, which ring you go with is all based on how much air you're moving through the house. In other words, how leaky the house is. Now, typically, I start out with what we call our A ring, which is just this outer ring here. This one is in. This ring is good for about 900 CFM to around 2200 CFM. I think our house is going to fall in that range, and so that's the ring that I start with. If I think it's exceptionally leaky, I would pull that A ring out and really move a lot of air. So since we're going with our A ring, we're going to want to program that into our DG700. It's currently set in the open configuration, and the way we do that is just by hitting the configuration button until it reads A1. So we're ready to turn the fan on, and you'll notice that I'm positioned to the side of the fan, so I'm not standing right in front of it there. And we'll just turn it on and move this up slowly. I like to move this up pretty slowly and then keep it at about 20 pascals and do a quick check of the house. Okay, so this is just something that I do. I like to check to make sure that I'm not pulling any ashes into the house. So we're looking pretty good here. I know it was clean before, but I always double check because if there were ashes in here and you're pulling them out, you can make a pretty big mess. All right, so we'll bring this up to 50 pascals, which is where we want to take our reading. And I still like to go slowly as I'm working my way up here. Now, if you notice the numbers aren't going up or they're fluctuating wildly, you may have excessive air leaks. Maybe you left a door open or a window. Maybe you have the wrong ring in. So I've got it stabilizing pretty good here. I'm going to go with 2100 on that. Let's go check for some air leaks. So much like I initially did the walk around on the house, I like to go to my right and just work around counterclockwise. And then I'm going around and I'm feeling. Basically, I'm feeling around any holes that we have. Actually, that's a pretty good bit of air leaking right through where that gas line is coming in. Now, if you can't feel it, a good item to use is a little smoker. And they sell these in all kinds of different configurations, but you can see that it just pops a little bit of smoke. Now we're getting some leaking out of this crawl space here, so I know that's a spot that maybe a little bit of weather stripping around there might help. I'm also going to want to go down and check that out and see if there's any other additional leaks in there. And so I'm actually feeling quite a bit of leaking out of some of these outlets here. This one actually has a good bit out of that outlet. Kind of feeling around at the windows here. You know, already I can feel a pretty good amount of air coming out of there. You can see that smoke just blowing through there, and feeling air coming in through this flue. Here's the penetration for the flue itself coming out of this wood-burning stove, and I do feel a good bit of air coming out of there, so that's accounting for some of this air loss that we're seeing. You know, what we're looking for is we're looking for things that we can fix easily to account for air loss. You know, we're not necessarily looking for every single bit of air loss. So most states will allow for duct sealing regardless of what those CFM numbers are, and I am feeling air, you know, coming out of some of this ductwork here, so we may have some duct leaks that can be fixed. You know, if they're exposed down in the crawl space, that might be an easy thing to do. I am feeling a good bit of air leaking out behind this mystery panel here, so it's probably a good idea to just open that up right now and see what's back there. You know, I'm feeling actually quite a bit of air as I open this panel up. We seem to have discovered the leak in this room here, and as it looks like it's not fully closed off as it goes down into that crawl space, so we would have seen that from underneath, which is why I mentioned earlier that it's a good idea to go ahead and check out the crawl space. So since we are seeing a lot of air leakage in here, but it's a pretty tight working area, we may or may not be able to do something with the air leakage inside here, which would help with a bit with the efficiency of this water heater here. But another option is to help with the overall efficiency of the home. If we can't get to the air sealing in there, we can probably run a strip of weather stripping just along this and put that panel back on, and that'll seal up some of the air leakage that way, at least from getting to the rest of the house. As I opened up this door, I did actually kind of feel that hot attic air. I don't feel a lot of air movement, but I can feel it and I can smell it, so I know we're getting a little bit of leaking there. If I get a little closer to those boards up there, perhaps I can feel some coming through the tongue and groove, but you know, it does look pretty tight. I really doubt we're gonna see much out of there. Well, and I can already tell that really nothing is going to be done with these windows as far as air leakage is concerned. These are some pretty tight windows. And of course I'm checking light fixtures too. You know, even if they're on interior walls, you want to check these things because they could be opened up into the attic space at some point. One other typical place is to check the plumbing penetrations underneath sinks. Typically when these are put in, you know, they're covered up, you don't see them. And so the jobs are a bit sloppier than in other places of the home, so they may have fairly large cutouts for the plumbing. But this one, it's quite tight. So you can see that smoke pouring out of there. The smoke makes it look a lot worse than it really is. I'm not feeling a lot out of the ductwork. Now I am feeling a good bit out of this window here. It's visibly in a bit rougher shape simply because of its location. It's exposed to a lot of moisture. There may be something that we can do to fix that up, but it's not a lot. Feeling a lot more air coming out of the outlets in the exterior walls than I am on some of the interior walls there. And of course we're back to where we started, so we'll check out this room and just you know, much like some of the other rooms, we are getting a little bit of leakage out of some of these outlets, but also like the rest of the house, you know, these windows are quite tight, so these are good windows. You know, one other technique that can go hand in hand with the blower door is the use of an IR gun. So while I didn't get up there to feel for air leakage, I am seeing quite a bit here with my IR gun. Even though I couldn't feel it, based on the IR gun, it looks like I'm getting quite a bit of air leakage around that beam as it's entering into the attic space. Up here where this laser is pointing, I'm getting some air leakage around that. You can see that hot air coming in. So IR work it's just an invaluable tool for things like this. Stay tuned for part 3 of our Blower Door Basics series, The Breakdown. WXTV, your online source for weatherization information, techniques, and expert advice.